Hi, everyone. Welcome to our presentation on cannabis and the brain. I'm Misty Cox, and I am part of Group 2, along with Javier Campos and Julie Wareham.
There are some names by which cannabis is also known as weed, pot, Mary Jane, grace, ganja, dope, herb, hash, etc. Some of the physical properties of cannabis include being different shades of green, having sticky leaves, and having a distinctive smell. Some people say it smells like earthy. And the way individuals use cannabis are smoking, edibles, teas, oils, and topical creams. Psychoactive substance half-life. Tetrahydrocannabinol THC has a half-life about 1 to 2 days for single use, but it can vary based on use frequency and individual metabolism. Common dosing. Dosing varies widely based on form. For smoking, a common dose might be equivalent of 3 to 5 THC, while edibles may range 5 to 10 milligrams per serving. About the overdoses and lethality, cannabis is not typically associated with lethal overdoses. However, excessive consumption can result in extreme anxiety, paranoia, and distress. DEA schedule classification. Cannabis is classified as a Schedule I controlled substance under the Controlled Substance Act, meaning it is considered to have a high potential for abuse and not accepted medical use in the U.S., although many states have legalized it for medical and recreational use. Chemical category and pharmacological properties. Cannabis contains various cannabinoids, THC, CBD, terpenes, and flavonoids, which produce different effects through the endocannabinoid system.
The basal ganglia, involved in regulating movement and reward processing, are notably impacted in cannabis use. THC binds to CB1 receptors in this region, altering dopamine signaling and affecting motor coordination and motivation. This can lead to slower movement, impaired coordination, and changes in reward seeking behavior, such as reduced motivation. The hippocampus, critical for memory formation and learning, is highly sensitive to cannabis. THC binds to CB1 receptors in the hippocampus, disrupting neural signaling and impairing the encoding and retrieval of short term memories. Chronic cannabis use, especially during developmental periods, can lead to structural changes such as reduced gray matter and long term deficits in memory and cognitive function. The hypothalamus, a key brain region regulating appetite, hormones, and homeostasis, is strongly influenced by cannabis. THC binds to CB1 receptors again in the hypothalamus, stimulating neural activity and increasing the release of hormones like ghrelin, which boost hunger, leading to the well-known munchies effect. This activation also impacts other functions regulated by the hypothalamus, such as body temperature, stress responses, and sleep cycles. You can dysregulate hypothalamic activity, potentially disrupting hormonal balance and circadian rhythms. Additionally, the hypothalamus plays a role in reproductive health, and excessive THC exposure may interfere with hormone levels related to infertility. The amygdala is the brain region involved in processing emotions. It is highly sensitive to THC, the psychoactive compound in cannabis. The THC binds to CB1 receptors again in the amygdala, leading to heightened neural activity and exaggerated emotional responses. This increased activation can amplify feelings of fear, paranoia, or anxiety, particularly in individuals predisposed to these emotions. The effect is dose-dependent, with higher THC concentrations more likely to trigger intense reactions. Chronic use may dysregulate the amygdala's normal functioning, potentially contributing to the long-term emotional instability. The prefrontal cortex is responsible for executive functions like decision-making, impulse control, and attention. It is significantly impacted by cannabis use. THC binds to CB1 receptors in this region, temporarily disrupting normal neural activity and impairing cognitive processes such as planning and problem solving. Chronic cannabis use, especially during adolescence when PFC is still developing, can lead to reduced gray matter and decreased functional connectivity. These changes may impair self-regulation, increase impulsivity, and reduce cognitive flexibility over time. Acute use can weaken the PFC's ability to regulate emotions and behavior, contributing to poor decision-making. While some effects may reverse with abstinence, heavy and prolonged use during critical development periods can have lasting impacts. THC interacts predominantly with cannabinoid receptors, CB1 primarily in the brain and CB2 in the peripheral nervous system. This interaction influences various neurotransmitters. Dopamine increases feelings of reward and pleasure. Serotonin, well, some studies suggest that THC can enhance serotonin release, leading to mood improvements. Others highlight that regular cannabis use can dysregulate serotonin pathways, potentially contributing to mood disorders. Norepinephrine. Cannabis may lead to increased levels of norepinephrine, which could enhance alertness or energy in some users. However, this activation can vary between individuals. GABA, the primary inhibitory transmitter influencing anxiety and relaxation. Glutamate, the main excitatory neurotransmitter affecting learning and memory process.
Let's look at the cognitive impacts of cannabis on the brain. First, there are significant effects on memory. Cannabis can impair both short-term and long-term memory and learning. Long-term effects do depend on usage patterns, especially in adolescence. And this has to do with the effect that cannabis has on the hippocampus. So when there's heavy cannabis use, the hippocampus is not able to operate as it's intended, and this creates impairments in short-term and declarative memory. Next, there are effects on social and interpersonal behavior. These effects can be both positive and negative. For example, a positive effect of cannabis is there could be an increased amount of sociability. An individual may be in a more relaxed state, and therefore they feel more able to be involved socially. However, negatively, cannabis use can cause anxiety, and instead of increasing sociability, promotes isolation. And this obviously depends on dosing and the individual responses. And that's because of the amygdala that's affected by cannabis use. The amygdala is where emotional processing takes place, and how we interact socially. Next is the impact on executive functioning. There is impulse control that's affected, decision making, and even cognitive flexibility, particularly in heavy users. And this is due to the effects on the prefrontal cortex. When the prefrontal cortex is not operating at its peak, there is impaired impulse control. Decision making is more difficult. There's a lack of planning or inability to make plans, and reasoning skills are diminished. So what about the physiological and behavioral impacts of cannabis? First, there's an effect on cognitive performance. So users may experience impaired attention, memory deficits, and even slower reaction times. Physiological adaptations and symptoms. Chronic use can lead to respiratory issues when smoked and cardiovascular changes. Withdrawal symptoms can include irritability and even insomnia. There's an impact on developmental processes. Early and heavy use can lead to adverse effects on the brain, particularly in adolescence. There are behavioral changes and social functioning changes. Cannabis can alter mood, increase risk of social withdrawal, or influence risk taking behaviors. Lastly, development of tolerance and dependence. Regular use may result in tolerance, requiring more for the same effect, and dependence, with withdrawal symptoms upon cessation, including irritability and cravings.